going to talk mostly about this question that's motivated my work for the last few years, which is what is the potential impact of climate change on diarrheal disease? This comes out of the global risk assessment framework that was developed a number of years ago to kind of estimate the impact of different risk factors on major diseases. And what they concluded in their last risk assessment, which included about 67 different risk factors, was there really wasn't enough evidence to include climate change in that estimation. And so I've been spending a lot of time trying to unpack the potential impacts of climate change on diarrheal diseases. And Anthony McMichael published over a decade ago this paper that I think is a really nice outline of what EPI can potentially offer the field of climate change and health. I'm an environmental epidemiologist by training. And he put forth three major tasks, So one was to analyze data from the recent past to clarify basic relationships between climate and health. So can we use observed data to date to really get at how temperature, rainfall, or other factors impact current disease? And then can we conduct scenario-based health risk assessments? And he said that, this second part is something that's outside a lot of our comfort zone because we have to make a lot of assumptions and move out of just risk factor epidemiology. But that's really how I'm going to structure this talk today, is spending about half the time talking about trying to get at this basic relationships between climate variables and diarrheal diseases, and then how can we use that information to project future disease burden. And this is really set up under this framework developed by the Global Burden of Disease Project to estimate risk of different risk factors, or the burden attributable to different risk factors. There's really three pieces of information that you need. One is the current burden of disease. And we've talked a lot about kind of getting at that. For example, what is the burden of CKD right now? Second is this relationship between climate and the disease of interest. So how is climate impacting this relationship? And lastly, what are the predicted changes in climate? And I think there's a lot of data integration issues here, in that if, for example, you estimate a relationship between climate and disease, and your climate prediction needs to be in the framework that talks to your climate-disease relationship. So, for example, if you estimate that heavy rainfall events are impacting diarrheal diseases, you need a climate prediction that looks at heavy rainfall events. So there are issues of getting data sets to talk across these different pieces. I think mostly about diarrheal diseases these days, and just briefly, diarrheal diseases are the number 4 leading cause of death and disability worldwide, and in low and middle income countries, they're number 2. They're the second leading cause of death in children under 5. So very small changes in risk attributable to climate change could have very profound impacts on health related to diarrheal diseases. So one of the first things I did in trying to get at this basic relationship between climate change and health was a somewhat serendipitous data analysis. I came into this project after all these data were collected, but a group, Joe Eisenberg's group at the University of Michigan, had collected weekly active diarrheal disease surveillance data for 3.5 years in 19 villages in northern coastal Ecuador. And they had also monitored rainfall in 4 different locations using hobo weather monitors. And I'd love to have an offline conversation at some point about the pros and cons of measuring rainfall, because we had some great success and difficulty there. But they defined diarrheal disease as having 3 or more loose stools in a 24-hour period within the last week. And we had 2 hypotheses. One was that heavy rainfall events impact diarrheal disease, and that the timing of these heavy rainfall events probably mattered. That there had been anecdotal reports that at the beginning of the rainy season, heavy rainfall events were much more devastating than later on. So we wanted to look at the impact of heavy rainfall events, taking account of whether it had been relatively dry or wet. And then second, we wanted to look at community vulnerability, and that the idea that in some places and maybe has better access to water and sanitation, the relationship or the vulnerability to climate change would be less than in places that had, for example, worse water and sanitation. And so we defined, we had maximum 1-day rainfall, or we had daily rainfall, and we summarized that over a weekly scale, and we did this because the health data was at a weekly resolution. And so we looked at whether or not there had been any single-day rainfall events that exceeded the 90th percentile in the past week. And then we classified these events based on the average rainfall in the past 8 weeks. So is this occurring in a relatively wet period, which you can see in red, or in a that's a dry period in red, or a relatively wet period, which you can see in black. And what we saw was this, and sorry, there's a lot on this slide, but we looked at 2 different types of lags, a 1-week lag and a 2-week lag. We hypothesized that given the etiology of diarrheal diseases, these are the lags that potentially made sense. So if the heavier rainfall event happens now, you're probably not going to see diarrheal disease spiking immediately, nor are you going to see it 6 weeks out, but plausibly, given the incubation periods of the different pathogens, we hypothesized 1 or 2 weeks. And what we saw is that 2 weeks, when it had been relatively dry, a heavy rainfall event in the past week led to an increased association with increased incidence of diarrheal disease. Interestingly enough, we found when it had been relatively wet, a heavy rainfall event was associated with a decreased incidence of diarrheal disease. And then we want to look at this issue of vulnerability. And for those of you who think in equations like me, I think about this as in terms of having some sort of climatic exposure and some sort of vulnerability that forms an interaction and leading to public health impacts. So we wanted to look at, whether having a heavy rainfall event times, your access to water or sanitation, I'll lay out our definitions in a second, produced affected diarrheal disease incidence in this population. And in terms of vulnerability, we looked at sanitation access, drinking water treatment, hygiene behaviors, which is an observational index that community health workers collected, and social cohesion. And what we found was that as on the x-axis here, you can see the percent of households that treat their drinking water. As the percent of households that treated their drinking water in a community increased, the association between heavy rainfall events and diarrheal disease incidence decreased. So that having more community water treatment, or having more treatment at the household level, at the community level, was decreasing or attenuating the climate effect, or the association, I should say. We did not find this association for sanitation, for hygiene, or for community cohesion. And I was absolutely convinced we'd see it for sanitation, and we did that. So at this point, what we really wanted to do, and what we were funded to do, is go ahead and use that data to make predictions about the potential impacts of climate change and health. And I think some of the Lee's talk yesterday, I think, fits in nicely here, in that we have one study with one set of estimates, and we could go ahead and make a whole bunch of global predictions about the potential impact of rainfall and health, and I think we'd be on very shaky ground, because while we may have temporality, we really don't have consistency. We really don't have mechanisms here for biological plausibility. So I'll just briefly mention, we decided not to go ahead and make predictions right then. Instead, we did a systematic review of the literature that was just published. And I think this is anecdotally one of the most interesting things we found. This is a photograph from a study done in the 1990s by a group of EIS officers. It was the first outbreak of O157 E. coli, and also followed by a cholera outbreak in the continent of Africa. And what had happened is there had been an extremely dry period. And you can see here this very dry riverbed. The cattle are grazing in this, on essentially nothing, very limited water flow. The cattle start to die off. There's enormous pressure on the limited water resources. Then there's a heavy rainfall event, and you see the O157 and the cholera outbreak happening. And there were numerous reports in the literature of this heavy rainfall events following dry periods leading to different disease outbreaks. We also did a study down in Guatemala that looked at the relationship between water contamination in domestic water sources and rainfall events. And this is a very small pilot study. I think it's more of a proof of concept than a proof of anything else. We worked in a region that had very unstable water access. This is a typical well in the region. So it's a household well, semi-protected, has a generator when the power is there. If not, you can use a bucket to draw out the well. Other households had wells like this that have no protection around them. A child had fallen into the well in the past year and been severely injured in this well. You can see the drainage right here, and you can imagine if there's a heavy rainfall event, it's not going to take much to lead to a contamination episode. These are some graphs that Andy Monahan helped produce. Here, looking at average rainfall in the region, we sampled during the wet period. And we looked only at 59 wells. So again, this is a small sample size, but we found a strong and consistent relationship between heavy rainfall events and E. coli contamination. And we found this relationship was strongest at wells that were lower in the watershed, so had a larger catchment area from which to drain from, and in wells where there were pigs nearby at the time of sampling, so a potential nearby contamination source. I think this gets at the variability in the relationship between rainfall events and potentially diarrheal disease outcomes, that you must think about context when measuring them. In general, we've found that the relationship between climate and diarrheal diseases is probably real, and it may work through contamination of drinking water sources, but the timing of the events, water and sanitation access, and some other work that I'm not going to describe here suggests that the pathogen is quite important here. I'm going to spend the rest of my time talking about these scenario-based health risk assessments. This is a study I worked on with a student, Maggie Hodges, who was at Emory and then was then a medical resident at the University of Colorado, who did a yeoman's work in putting this together. But the question was, what's the potential impact of climate change on waterborne disease in China? So we're looking at the larger issue of waterborne disease, although because I think 90 to 95% of our estimate was due to diarrheal disease, this is really about diarrheal disease. But to talk about estimating the potential impacts of climate change on diarrheal disease, there are a couple of things we need to keep in mind. First, diarrheal diseases in general are largely a success story over the last 20 years. This is the millions of deaths per year due to diarrheal diseases globally. And you can see we've come a long way in reducing the burden of diarrheal diseases. And this is particularly true in China, which has seen about a halving of the burden of disease due to diarrheal diseases from 1990 to 2010. So to assume that climate change, that the baseline risk of diarrheal disease is going to stay static and only climate is going to change, I think would be quite disingenuous. So can we build a model that somehow accounts for this ongoing decline in climate change, in diarrheal disease over time? At the same time, there's been large progress in improving access to water and sanitation. We're not where we want to be with sanitation, but in general and globally and in China, there's been large increases in people's access to sanitation, which also needs to be taken into account. And of course, because we're talking about China, there's been enormous demographic change. This is a histogram of the age distribution in the villages where I work studying schistosomiasis, a different work. But what we see is this missing population in the rural villages because of massive rural to urban migration. And that will impact diarrheal diseases in terms of who is located where. So what we attempted to do is to use this framework to estimate future disease burden under a range of changes in temperature. We limited this to temperature only, and we can talk about that. And we made some assumptions about the relationship between temperature and diarrheal diseases. Primarily, we assumed that it depended on sanitation access. In the end, this didn't have a large impact on our estimates. And then we used, to estimate the burden of diarrheal diseases, we modeled population growth, urbanization, and different infrastructure investment scenarios to get at the fact that this is not a static measure, but something that is also changing at the same time as climate. So you can imagine that this is going to produce estimates that overall that diarrheal disease burden is going to decrease. But we, and by we, I really mean the other co-authors on this paper, came up with this metric called a development delay. So this is the projected decline, and this is just a schematic, in diarrheal diseases in the context, in the absence of climate change. And this might be the decline in diarrheal diseases in the presence of climate change, so that you still see decline, but the rate of decline has slowed. And so you can talk about the development delay as the number of additional months it would take you in the presence of climate change to get to where you would be in the absence of climate change in 2030. And we picked this arbitrary time frame. So what is the number of months that we are delaying progress in reducing diarrheal diseases? We used the 4 different relative concentration pathways, and we also predicted 3 different levels of safe water and sanitation infrastructure, essentially holding everything flat, which because of population growth is actually increasing the number of people with access to water and sanitation, but holding the percentage constant, a linear growth model, and then an exponential growth model. So there's a lot going on in this table, but the big picture here is that here are the 4 different RCP scenarios and the reference group. This is kind of the absence of climate change. And for each one, we looked at the 3 different water and sanitation investment scenarios. So you can really, in parallel, look at different emission scenarios and different, let's say, adaptation scenarios, and look at their impact on diarrheal disease burden. And you can see for RCP 2.6 with exponential investment in water and sanitation, the development delay will only be 13.1 months, whereas if we have RCP 8.5 and maintenance scenario for water and sanitation, the development delay could be 62 months. And there's a lot of imprecision here in terms of our estimates, but I think what is interesting here is I think it shows it's possible to integrate both climate and infrastructure investments and population growth in a single model. So the conclusions of this paper was that climate change has the potential to delay the progress in China in reducing waterborne disease. And moreover, I think there's a lot of weaknesses in this analysis, to be frank. We only looked at temperature. We had to make a lot of assumptions about the relationship between temperature and diarrheal diseases. But I think it's a framework that can be used as we improve estimates of the relationship between temperature and diarrheal diseases, or begin to incorporate estimates of heavy rainfall and diarrheal diseases, or to move this to other disease systems of integrating concurrent changes in demographics, socioeconomic growth and development, and climate change, and then projecting different health outcomes. And I think this is a very useful framework, particularly from one who works in global health, is thinking about climate change as an impediment to continued health improvements. I think sometimes the global health community is tempted to ignore the issue of climate change because there's so much else on our plate. There are a number of challenges, and I think ignoring that really is at our own peril, because I think it is impairing progress in other ways as well. So I'll just say the next thing on our radar is to try to look at the consistency of our findings regarding rainfall and temperature using a larger multinational pathogen-specific diarrheal disease database, and Balaji and Andy have been involved in putting together this proposal. And I finally just wanted to say thank you. This is the work of many people, including Andy Worcester and Ian Eisenhower, my students, Karen Levy, my collaborator Emery, Andy Monahan stepped up and did some really interesting work for the Guatemala study, Justin Ramez I work with, and then Joe Eisenberg's team. And lastly, I want to say that the Ecuador work that we did was funded by an R21 that was a climate health specific call that has not been renewed, and is the only federal funding we've been able to attain for any of this work. This has really been cobbled together on a shoestring since then. So thank you.
Great. We have a lot of time for questions. Jonathan?
Yeah, originally you were talking about the timing of rainfall and that more cases following dry periods. What I didn't. Could you sort of? What's the conclusion? What's the finding?
Yeah, sorry.
And an explanation for
why.
I mean, I have my own hypothesis, but I just was wondering what you found.
So what we found is that if a heavy rainfall event happens when it has been relatively dry, so when the average eight-week rainfall has been low, there is an increase in diarrheal disease incidence. And the thought there, if we go back to the fecal veneer that someone mentioned yesterday,
There's more out there.
There's more fecal veneer that's allowed to build up. And conversely, and if it's been relatively wet, we saw a protective effect, which surprised us, but we're epidemiologists, we have to observe what we observe. But the thought is perhaps at that point there's been some flushing events.
So my follow-up is just that how pervasive is that throughout the literature? And could that be another question for the climatologist to give us this sort of intermittent, the periodicity of heavy rainfall and that type of, the flashiness of that type of behavior?
Mm-hmm.
A two-part question. The decline of diarrhea.
Sorry, can I just finish? Sorry, I thought you were going to comment on what Jonathan said, and then sorry. We were surprised to see, mostly in outbreak reports. So in our systematic review, we compiled both more traditional epi-analyses and outbreak reports. A number of outbreak reports reported diarrheal disease outbreaks following dry periods. So heavy rainfall events following dry periods. So we think this is not just a one-off finding. But I think part of our motivation for doing this new analysis is really looking into that at a multinational scale.
I was wondering, is the decline in global incidence of diarrheal diseases, the global I'm talking, largely from China and to whatever degree from India? Where is it coming from? So geographically, where are the numbers coming from?
It's been a really global success story. So I think the introduction of oral rehydration salts, more aggressive case management, introduction of rotavirus vaccine. So it's not just China and India driving this.
And then in the last 20 years, the sort of development of failed states, with, you can see a number of them in Africa, Middle East, and now Venezuela is moving in that direction. So is that going to be a retrocession where you'll actually, the decline of the infrastructure and sanitation infrastructure lead to increases in such diarrheal disease?
I mean, I think that's a spot-on question. And what's happening in Syria over the past 4 years, what's happening in Venezuela now, there's lots of concerns, not just about diarrheal disease, but as Anna was mentioning, seeing malaria spill over into Ecuador now. Yeah, that's certainly a concern.
Jerry?
So just related to this rainfall frequency connection, this is actually one of the indices that we do calculate called dry days. So you count the number of days in between rainfall events and keep track of that, and then you actually calculate rainfall intensity. So for the projections, rainfall intensity is projected to increase almost everywhere, which is it's already been doing. We're very interested to look at it. But in semi-arid areas, the dry days also increase. So basically, you have a longer time period between rainfall events, and then when it rains, you get actually a heavier rainfall event. So I'm assuming that is bad, right?
Yes. And in the US, there's concern. There's been a really nice paper that came out recently about combined sewer overflow events related to heavy precipitation events. And it'd be interesting to look at, if it's been dry or longer, and then you have a CSO event, is that even more hazardous?
So the diarrheal cases, when they get reported, often it has to emerge or evolve into something other than simple diarrhea. So how is that? So how do you distinguish that between just garden variety diarrhea versus this has now transformed into something? I would wonder, most of the common diarrheal would be treated by over-the-counter medicines that wouldn't even know. So are these like acute cases or?
So, I mean, I think one of the biggest challenges is getting at the burden of disease piece of things. diarrheal disease is tricky because it's not one disease. It's caused by many different pathogens. And in fact, it's caused by things other than pathogens, taking different medicines, being stressed. There's all sorts of different causes of diarrheal disease. In this case, we just did active surveillance and asked if anyone had had 3 or more loose stools in the past 24 hours. So that could be a fairly moderate or a fairly severe case. The database that I'm hoping to work with multinationally is people who are sick enough to present to a clinic. And there's another multinational database that's also doing the active surveillance at the household, so just any 3 or more loose stools. So depending on how you define it, it can be different things. But I think more useful is to have pathogen-specific diagnoses, because we know diseases like rotavirus are seen in the winter, whereas most of the bacterial diarrheal diseases seem to be temperature-driven in a positive way. So yes, I mean, I think this question, like diarrheal disease, is just this basket of etiologies, and so maybe to understand what's going on is to tease out the different pathways individually. But,
to that, and thinking about how diarrheal disease in infancy contributes to malnutrition, and then if you have climate change affecting agricultural availability, and you have diarrheal disease on top of that, that's again an effect multiplier, something to consider.
yeah, I mean, diarrheal disease can really take a kid off their growth curve, particularly if with lower respiratory infections, they can play a nasty game together in malnutrition.
So can most of that be traced to again sanitation? Because in India there was a recent article, I think a couple of months ago, that point to, even though the general economy is improving, people are moving up the social status, that because there is so much defecation outside, that even wealthy people or moderately wealthy people are not immune, and then they're finding the kids are stunted growth and so forth. Is that something? How is that? Or climate is one piece, but if this is something that's chronic, it's there unless you change.
Yeah, I mean, the truth of sanitation is it really doesn't matter if you have a toilet. It matters if your neighbor has a toilet, right? So, I mean, I think this gets to some of the points that Jonathan was raising in terms of these no regrets or co-benefit strategies, that investing in sanitation to prevent the health impacts of climate change is, what if climate change is a hoax? Well, then we have sanitation finally. Yeah.
All right, thank you,
guys.
Beth.